Get settled, a few reminders before we get started. Please remember to be constructive in your comments and questions to the presenters and to one another to ensure that we have a session that is productive. Additionally, please do not use the chat box to ask any questions for today's panelists. Instead, use the Q&A. With the Q&A feature, attendees can like a question to move it to the top of the queue. We will answer as many questions live as time will allow, but we will answer all open questions offline for those to be sent in a follow-up email. And as always, the webinar content and additional resources will be available online shortly after the session. Today's webinar, which will focus on safety standards related to design, construction, and installation methods of automated vehicular access points, is brought to you by High Security. It qualifies for one AIA HSW learning unit for those watching live, and AIA California will report those units for you once you have finished the full session. Now, to quickly introduce our presenter. Brad Richards has been in the automated gate industry for 14 years and has been a member of the High Security team since 2009. As a specification sales engineer with High Security, it is his focus to work with architects and engineers as a consultant. He assists with writing specifications for automated gate systems and provides design guidance for those systems to ensure that project meets the client's needs, while also conforming to the UL 325 and ASTM F2200 safety standards. He holds the Certified Gate Operator Design certification from the AFA. Now on to today's presentation. Welcome, Brad, and thank you for being here today. Please take it away.
All right, thank you very much. Hello, everyone, and welcome to How to Design a Safe and Compliant Automated Gate System. So my role with you is to assist you in the design phase of your projects. I can help review your project needs, select the appropriate equipment, make sure all UL and ASTM safety standards are met and all the components are integrated successfully. And I'll provide my contact information after the presentation. And I'm going to go ahead and stop my video so it's not distracting for the rest of the presentation. We'll get going here. So anytime you automate a vehicular access point, UL 325 and ASTM F2200 safety standards are what come into play. So Underwriter Laboratories, they generate the UL 325 gate operator standard. It covers the machine that moves the gate, whereas ASTM generates the F2200 standard, and that governs the construction of the gate as well as all the parts and pieces integrated so that you're not creating pinch points and hazards. And you can visit these URLs here to learn more about these standards. So as of 2018, August 1st, 2018, there were a couple of things that changed about the standard. It requires the manufacturer to define entrapment zones for all types of gates. And the number 2 bullet item here kind of really boils it down into one bullet here. So it requires 2 independent means of monitored entrapment protection for each direction of travel for slide gates, but only one direction, which is the closed direction for swing gates, unless an entrapment zone exists in the open direction. So that's quite a mouthful and it's a lot. We're going to get into it, but some of the changes here are that the safety devices required here are to be monitored. In other words, the standard requires the manufacturer to build the operator, so it's looking for the existence of these monitored entrapment protection devices, such as photo eyes and gate edges. So if those devices aren't installed and installed correctly, the gate operator is not going to work. So it's really holding the feet to the fire for the installer and everybody putting this together. And so the other things are that it requires us, the manufacturer, to list compatible and approved devices in our manuals, and requires the manufacturer to show entrapment zones and tell where and how to protect each of these in our manuals. And it also disallows the use of jumpers, resistors, and switches, which some nefarious installers may use to get around these standards. So you'll hear from some that UL and ASTM standards are voluntary. It really is not the case. Nothing could really be further from the truth. Nevada became the first state to embrace these back in 2001, followed by Louisiana and Florida. And by 2014, more than 50% of the states and municipalities included these in their building codes. OSHA uses this standard as a condition for compliance at the federal level. And UL 325 can be found in the IBC International Building Code. So these are definitely not voluntary standards. This is all about liability, and if somebody does get hurt on a gate, it does go to court. You want to make sure that you're able to say, yes, I did design this system compliant with these standards. So moving gate can cause serious injury or death. Unfortunately, these things do happen. A couple examples here. The one on the left is an HOA community in Las Vegas. There were a couple of young boys that would go in and out of facility here. They would actually crawl through that rectangular shape. This is kind of an odd installation of a pad-mounted swing gate. You can see the scissor arms are actually going through the fence line, and there's that rectangular section there that if it were per code, per the standard, it would have been brought down to 2¼ inches. In this case, it was big enough for one of the kids to actually crawl through that space, and then his friend dropped his bike being metal, activating the free exit loop, and the gate started operating, and it squished, and unfortunately the young boy perished. The one on the right is a slide gate. In this case, there was improper fallover protection. This slide gate became detached from the operator while moving, and it fell over and hit a young boy on the head, and that was not a good situation either. Another example here on a slide gate as well. This gentleman was leaving the Dickey Stadium. I believe he was a janitor getting a ride home, and he was able to reach through the slide gate and activate the gate with his arm through the gate. And unfortunately, that caught him up and got him caught up in the gate, and unfortunately perished there as well. So a couple things here. The access control device should not have been close enough, should be 6 feet away, actually, per the standard. So that you can't reach through and activate the gate. And then secondly, the gate should not have had the gaps in the pickets such that your arm could go through and reach through the gate. So automated vehicular access points, they're more than just the gate, they're a full system, right? The system includes multiple external inherent safety devices, such as access control, the gate itself, the gate operator, locking mechanisms, vehicle sensors, all that. These components are typically manufactured by separate companies, and they need to work together seamlessly to provide required security, also the throughput, and of course, the biggest thing is safety, right? So an automated access control point, they can be hazardous to people or cause damage to vehicles when designed without adequate safety considerations. So as a specifier, you should know how to specify the proper equipment and proper safety devices that will result in a safe installation. So really, safety is the most important design consideration, even for something like a nuclear power plant or an airport or a DoD facility, something where security is very top on the list, but safety is certainly also top of the list for your criteria. So again, UL 325, it governs the machine that moves the gate along with the entrapment protection devices. It also calls out the specific installation requirements like signage and the placement of safety devices. UL listed operators, they're tested by an independent laboratory such as ETL, which is who we use. They'll test the gate operator and accessories and certify that they meet the UL 325 requirement. You'll notice this first bullet here in the slide calls out 325 as a voluntary listing and labeling program. So while manufacturers can bring a gate operator that's unlisted and unmarked to market, the liability associated with that equipment is pretty high. Under most jurisdictions, if the site is inspected, installer or end user will be informed it doesn't comply, doesn't pass code, and they must replace the operator with a UL listed operator or bring it up to standard. So the most accessible and reliable resource for the UL 325 standard is going to be in the gate operator manual. So at the end of our manuals, you'll find the most current information related to these standards. And these documents also have to go through independent test laboratory scrutiny and pass the test to be compliant with the standard as well. So we offer a CSI formatted 3-part spec language for all of our operators. And this is something where I can help you out. I can help write your specification. We do have boilerplate spec language for each one of our operators. And they'll call out all the specifics related to the standard. And you want to make sure you're specifying a gate operator that's UL listed and marked for UL 325. Also want to call out the qualification of workers. Make sure that they're thoroughly trained and experienced for the equipment they're installing. And our spec language is going to call out the qualifications for the installer. So the installer must have a minimum of 3 years experience installing similar equipment and has been to our factory training within the last 3 years. So installation is very important on this stuff to make sure that they know the standards and they're putting the equipment in appropriately. So listed and marked, it's a critical specification term, the term UL 325 compliant. You know, it can be self-declared by some manufacturers. They might have a couple of checkoffs for the standard, but they haven't gone through the lengthy and costly process of sending their equipment through a third-party laboratory, getting it tested, listed, and marked with a sticker on the operator. That's going to look just like this. So you want to make sure that the operator does have in this case, an ETL third-party laboratory sticker that is calling out the operator is compliant with and has been tested to the standard of UL 225. Also, you can see the sticker is calling out the Canadian version of the standard called CSA. So UL breaks their sites into 4 classes. They range from single-family residential to restricted access and high-security installations. So UL usage class 1 covers all single family up to sites with 4 homes. Because of the presence of children in class 1 and 2 sites, you know, sliding gates must have a speed limit of 1 foot per second or slower. In other words, you cannot go more than 1 foot per second in a class 1 or class 2 site. Very important distinction between class 1 and between class 1, 2, and 3. Get into 3 and 4, the speed limit is unlimited. Usage class 2 covers any multifamily residential application in excess of residences, 4 residences. And this is going to be something more like a commercial environment, like a office park, that kind of thing will be considered class 2. So class 1 and 2 are going to be characterized by general public access for the most part. And again, class 1 and 2, when it comes to slide gates, has a speed limit of 1 foot per second. There are operators out there that will go as fast as 3 feet per second and carry up to a 5,000-pound gate panel at that speed. So you want to make sure that you're very, concerned with what particular UL class you're working with, and that's going to tell you what type of operator you're going to specify. Class 3 is going to be more industrial in nature. It's going to be characterized by people with credentials. So they can have a card key or a code to get through here. It's not going to be general public. It's going to be what we call trained users with validation to get through. And it's going to be characterized by typically an industrial type of a site that's off the beaten path. It's not going to be accessed by general public, and it doesn't have neighborhoods or crosswalks, or sidewalks going by it. Class 4 is restricted access. So that's going to be things like DoD facilities, petrochemical sites, prisons, police stations, fire stations, that kind of thing. The photo here that you see is United Nations. That's a classic example of a class 4. You can see this is a swing gate at the front here, and the sequence of operations, this vehicle would come up, the swing gate would open, let the vehicle through. The swing gate would close behind, and they would stop in front of the barrier arm. So it's kind of a sally port, if you will. The guard's going to come out and do their the mirror under the car and check everything's okay, give the thumbs up, and going to let the vehicle through by opening the barrier arm on the other side. So that's a typical class 4 environment there. So this chart is directly out of the UL 225 technical data sheet. It labels and defines the appropriate safety devices to be used for each type of gate operator. So it's kind of a cheat sheet, if you will. It's a little convoluted, and I'll kind of go through it here. So basically, it calls out and labels the different types of safety devices to be used. Now, remember we talked about UL 325 requires that the system has two independent means of entrapment protection covering both open and closed direction of the gate in terms of slide gates. So if you're looking at a slide gate up here, you see that you've got slide, vertical lift, and vertical pivot gates. So it's required by UL 325 that we build into the operator what's called a type A or inherent entrapment sensor protection system. So that's already built into the operator. And so you have your primary means of entrapment protection built into the operator, and you're left to decide on the secondary means of entrapment protection. That's going to be a choice between the type B1 or B2. So type B1 is a non-contact sensor, otherwise known as a photo eye. And B2 is a contact sensor, what we call a gate edge. So photo eyes, of course, are an electric beam like you'd have on your garage door. And if somebody breaks that beam, the gate's going to stop or stop and back up, however it's set. And in the case of a gate edge, that's a contact sensor. So that's going to be basically a rubber bumper. It's got a circuit inside, and that when the gate hits an object, it crushes that bumper, makes connection with that circuit, and tells the operator to stop and back up because it's hit an object. So in the case where you're working with a UL 325 compliant operator, it's going to have the type A built into it, inherent entrapment protection system. And then you choose between either a B1 or a B2 or the combination of the two to protect both open and closed direction. And then the same thing with swing gates and barrier arms. So rather than the type A, the swing gate and barrier arm is going to use a type C. So a type C device will break away when there's more than 40 pounds of force applied. So it is basically its version of the inherent entrapment protection system. It's just done in a different way. So they're working with swing gates and vertical barrier arms. We're working with a type C for the inherent system. And then you're left to decide on the secondary means of entrapment protection. So type D is a button that controls the opening and closing of the gate operator, but requires continuous pressure for the gate to continue to operate. So this is a typical scenario for a class 4 environment. So let's say it's a prison. It's required to have line of sight either through video or in person of that gate moving. And so the person would hit that type D button, the gate would start moving, they'd let go of the button, the gate would stop. So they have full control over the movement of that gate through the type D button. So in the case of a class 4 environment, they would, in most cases, let's say it's a prison, they would not have any of these other safety devices. They would just have the type A inherent entrapment system built into the operator. And they'd have this secondary means, which is the type D button, as long as they have line of sight of that gate moving back and forth, either through video or in person. So when it comes to the inherent entrapment sensor, it works a little differently depending on what type of gate operator you're working with. The one on the left is a hydraulic operator. The one on the right is electromechanical. So they're both slide gates. The inherent entrapment system in the hydraulic operator is going to be a hydraulic sensor or a pressure sensor. So when the gate typically is moving at 750 PSI, normal operation, the installer will set maybe 200 PSI above that for the sensor. Gate hits an object, it's going to see a spike in hydraulic pressure. When it hits that and knows it hit something, it's going to stop and back up. On the electromechanical operator on the right, this is electromechanical chain-driven operator. It's going to have the same end result, but it's going to be a spike in current that it's going to see. So it hits an object and it can continue to push against that, see a spike in current. It's going to notice it's hit an object, stop and back out. So that's the inherent entrapment system for slide gates. Again, the type C, which is the inherent entrapment system for the barrier arm and swing gate, that's going to be a force limiting device that will activate when there's more than 40 pounds of pressure applied to the gate. So end result is kind of the same. It's all about safety. So when it comes to photo eyes, we recommend using through beam photo eyes. This is an example of an outdoor rated photo eye here. There are two types that will work and that are compliant. There is retroreflective and there's through beam. So the reflective style is not going to require power on both ends. It's going to send one direction and reflect back. Whereas the through beam is going to require power across the lane because it's sending and receiving from both ends of the unit. We recommend using through beam photo eyes because they are more reliable. They're not going to be susceptible to sunlight and debris and that kind of thing. So if it's possible, we recommend going with through beam photo eyes. Gate edges on the right here is an example of context sensitive gate edges. These are typically be about 5 feet in length. And there's going to go typically on the leading and trailing edge of a slide gate. And you can use also what's called a wraparound edge for swing gates, which we'll get into in a bit here. And then you've got an example of your type D continuous pressure button, typically used in class 4 environments. So this is a list of all the safety devices that we've tested to be compliant with the UL 325 for our gate operators. So this is a list that's available off our website, or I can send it to you upon request. This is available to you, and it shows you the different photo eyes. You can see that we've got the retroreflective here, as well as the through beam options, and then you can tell what the max range is on each one of these. So these are all compliant with UL 325. And then we've also got our edge sensors down here. So gate edges, when applied to the leading and trailing edge of a slide gate, are going to typically be wireless in nature. They're going to have a transmitter box attached to the gate, communicating with a receiver inside the operator. And so most of these are going to be wireless, but then you can also use a hardwired edge in certain scenarios, which we'll get into in a second here. But all these are listed here on this list. So this is an example of an installation where they've used photo eyes to cover both the open and closed direction. Remember, it's required to have 2 independent means of entrapment protection covering both open and closed direction on a slide gate. So you've got your inherent entrapment sensor built into the operator, and in this case, you've got photo eyes covering both open and closed direction. So the old standard used to be just to cover the lane. So in other words, the closed direction. Now the new standard requires that you cover both open and closed direction. So photo eyes, typical installation is about 5 inches off the face of the gate and between 21 and 27.5 inches off of grade, typically post mounted. And these eyes, again, are going to go covering both open and closed direction in most cases, unless you're using a gate edge for the other direction, which is possible. And in this scenario, in this system, they've utilized the context sensitive gate edges on both the leading and trailing edge of the gate, covering both open and closed direction. So you can go either gate edges or photo eyes, or a combination of the two to accomplish your compliance with the standard. So we talked about putting gate edges on both the leading and trailing edge of the gate. There are cases where you might need to put a hardwired edge. So typically, these gates edges are going to be wireless in the leading trailing edge of the gate, whereas these will be wired into the operator. So they'll go through a conduit and up into the operator. This is on a stationary device. So the only case where you need this gate edge is if there is an entrapment zone existing between the gate and the guidepost. So the definition of that is if the gap between the gate and the guidepost is greater than 2¼ inches, but within 16 inches, that's considered an entrapment zone. So you have 2 options there. You could fill that in with material and bring that gap down to 2¼ inches, which would make it compliant. Or you can install a hardwired edge here, and which would also be compliant. So if little Johnny's going to ride the gate and he gets sucked into here, it's going to hit the gate edge. The gates can actually stop and back up and let him spit him back out. So that's kind of the reason for that, and we'll get into that in a little bit here. A couple things to know about gate edges. With photo eye, of course, is non-contact. Gate edge is a contact sensor, so it does need to hit something to work. There's also batteries because it is a wireless device. Those batteries are typically going to last about 2 years. You need replacement at that point. And the gate edge is subject to climate wear. Typically they'll crack and needs replacement at some point down the road. So here's an example of a commercial class 2 slide gate installation. So this being a class 2 site means that for a slide gate, that gate operator could only be 1 foot per second and cannot be any faster than 1 foot per second to be compliant with a class 2 installation. In this case, that operator is UL listed and compliant. So it's got an inherent entrapment sensor built in, and they're using the photo eye sensor for both open and closed direction for compliance. In this scenario, it's a single family residence, class 1, UL class 1. So again, speed limit on that slide gate is 1 foot per second. Again, in the scenario, they're using a UL listed operator, so it does have an inherent entrapment sensor built in as the primary means of entrapment protection. And then instead of photo eyes, they're using gate edges on both leading and trailing edge of the gate. So having gone through all those scenarios, the recommended approach for compliance with this standard is to utilize photo eyes. Reason being, a lot of these installations are going to be industrial environments that can have a lot of radio frequency traffic in those areas, which can tend to cause havoc with the wireless gate edges. So if you're putting gate edges on here as a wireless, and you've got the RF communication into the operator, oftentimes there's too much traffic in that area and it's causing issues with the gate edges, and there's a lot of maintenance calls to come out, hey, this gate's not working, and oftentimes it's the wireless edge. So what we recommend doing is working with photo eyes to cover both open and closed direction, and then utilize a hardwired edge in the case where there's an entrapment zone existing between the gate and the fence line. Again, that definition is if the distance between the gate and the fence line is greater than 2 1/4 inches or within 16 inches, that's considered an entrapment zone and require either some material to bring that down to 2 1/4 inches or utilizing a hardwired edge like shown in this graphic. So when it comes to swing gates, we mentioned the swing gate is only required to cover or protect the closed direction. So you'd have a photo eye across the lane here, unless there's an entrapment zone existing in the open direction. So if this swing gate, when it's in a fully open position, is up against a fence line or a wall, and that gap is within 16 inches, then it's considered an entrapment zone and will require a photo eye in that area. Additionally, when using a pad mounted swing gate like you see here, the scissor arms are going to come back. This knuckle is going to swing back in the open direction. That's going to cause an entrapment zone as well. So if that knuckle is within 16 inches of that wall, then that needs to be covered as well. So you want to make sure your photo eye is covering that area. Additionally, on the leading edge, you can put a wraparound edge here. I say wraparound because that's the type of edge you would put on a swing gate. Wraparound edge is going to activate from multiple directions because the swing gate is sweeping rather than the slide gate going in one direction. When it comes to the bottom of the gate on a swing gate, if that bottom post is greater than 4 inches off grade, then it would require a gate edge. If it's 4 inches or less, it does not. Additionally, where the swing gate is hinged is important, because as this gate opens, if it's up on a pilaster like it's shown here, if when the gate opens in this full open position, if that gap between the hinge and the end of the pilaster is greater than 4 inches, that's considered an entrapment zone. So you want to be concerned about where that hinge is being placed. You want to make sure you place it farther enough away so that that gap between the hinge and the end of the pilaster is less than 4 inches. UL 325 used to require audio alarm. It is no longer a requirement of the standard. However, they are built into all operators regardless. It's just a good safety item to have. Those can be deactivated at will, but it's not required for the standard in order to be compliant. And warning signs. So UL requires all manufacturers to put this lovely warning sign in the box. There's going to be 2 in every box because it's required to place these on both the public and secure side of the gate. We train our installers to make sure those are installed, take a picture, have the end user sign off that those were installed, and off they go. So this is really, as simple as this is, probably the most important item. If somebody does get hurt on the gate and it does go to court, the first thing an attorney is going to point to, will ask, were there warning signs on the gate warning people of the hazard? Anytime you automate a vehicular access point, it's required to provide a pedestrian access. There needs to be a separate way for pedestrians to get into the facility rather than walking through the actual vehicle access point. So this brings up a lot of questions usually. It's not required necessarily to have a pedestrian gate for every single vehicle access point. It just needs to be a common sense place or way for pedestrians to get into the facility rather than walking through the vehicular access point. So hopefully it's obvious not to do this. This is actually a daycare center, believe it or not. And they put the pedestrian gate in the gate. You can actually reach up and automate the gate as you're walking through it. And there's a lot of reach through hazards here as well with those pickets. But just make sure you don't specify something like this. You want to make sure that the pedestrian access is separate from the gate itself. Example of pedestrian gates done correctly. You want to make sure that there's signage on there, making sure the pedestrians know which way to go. They're not going to walk through the access point. And there's nothing that really talks about how close the pedestrian gate needs to be. This is compliant. It doesn't need to be any particular feet away from the moving gate panel. But you do want to make sure that you provide a separate access for pedestrians. When it comes to access control, remember we talked about the guy at the Dickey Stadium. He was reaching through the gate and activated the gate while his arm was through the gate. So this is what this is all about. When you have access control devices such as card keys or keypads, that kind of thing, those devices need to be no closer than 6 feet from the moving gate panel, 360 degrees around the gate. So it can be further away for sure, but no closer than 6 feet. So you can see you want to make sure people are not reaching through the gate like this and activating the gate. So the example on the right is not compliant, and the example on the left would be compliant at least 6 feet away. When it comes to barrier arms, they actually don't fall under the standard unless a barrier arm is moving within 16 inches of a fixed object. So that could be a bollard or a fence line or whatever, but if it's out in the open by itself, it does not require any additional safety devices other than the inherent entrapment sensor that's built into the operator. So if it's moving within 16 inches of a fixed object, then yes, you do want to make sure you provide a safety device. And that would be a photo eye. It's not a good idea to put gate edges on an arm. It's going to create some weight to the arm and mess with the open and close limits settings for the operator. So the best way to approach a barrier arm is using a photo eye directly under the arm. So I mentioned it's not required if it's out in the open. I do recommend people specify a photo eye for barrier arms. It's just a good idea. They're not very costly, and it's a good way to go. In this graphic, you can see that there are in-ground loops. So if you're not familiar with loops, the loops are not part of the UL 225 standard. They're more for vehicles, whereas what we're talking about is safety for people. But loops are still very important. You don't have in-ground vehicle sensor loops. You will hit vehicles with your gate. So if you're not familiar with loops, real quick, basically what they are is a saw cut into the pavement where the installer is going to lay in loop wire. Off the corner of that loop, they'll run a conduit up into the operator, and the leads of that loop will terminate on loop detectors. So that loop wire is going to create an electromagnetic field around the wire, 360 degrees around the wire, and a certain amount of that field or signal is going to come up off of grade, usually about 4 feet off of grade. And it's driven by how wide your short side of the loop is. I won't get into that, but there's a signal that gets up off of grade, and when the vehicle drives over that loop, being metal, it deactivates the loop signal, tells the operator, hey, I've got something in the way, don't go close. Vehicle drives off that loop, the loop retains its signal. The operator says, okay, I'm free and clear. I can go ahead and close my gate without any obstructions. So there's numerous varieties of loop configurations and reasons for loops. The main reason is to identify vehicles in the way of the gate. You can also utilize loops for free exit out of the facility. And there's also overspeed and wrong direction detection, that kind of thing that we get into. So if you are specifying a barrier arm, just make sure you specify a good quality one that's got a good bumper on the bottom. If it does hit an object or a vehicle, it's not going to make too much damage. In this picture here, you can see there's two operators. There's an automated swing gate and a barrier arm together. Obviously, in this scenario, it got an open command and both went open at the same time. But what can happen here is you can actually connect the two, network the two together so they know the existence of each other. And you set up in the programming sequencing. So that would be where the swing gate would go open when it hits its open limit. Then it allows the barrier arm to go open and let the vehicle through. So it's a form of traffic control. It can also be utilized for tailgate mitigation, that kind of thing. So let's jump into ASTM F2200. We just covered the UL 325. So as I mentioned, ASTM 2200 is all about the construction and installation of the gate and the hardware, such that you're not creating pinch points or entrapment zones. So the standard was it was established back in 2001. It dovetails with UL 325. So anytime you automate a vehicular access point, both these standards come into play. ASTM F2200 is certainly very important. You'll find a lot of manufacturers build the gates in compliance with the standard, but in a lot of cases, customization is going to be required to meet the standard. So when it comes to slide gates, as I mentioned, a entrapment zone is defined as a space between any part of the moving gate and the stationary object. So in this example here, a cross section of a slide gate, if the gap between that gate and the fence line is greater than 2¼ inches, but within 16 inches, it's considered an entrapment zone. That's the gap right here we're talking about. So a couple options. One is to use some shielding or material to bring that gap down to 2¼ inches, which makes it compliant. Or as I mentioned before, you could utilize a hardwired gate edge. So a couple examples here, gap without filler is 5 inches here. They put the filler in, brought it down to 1¼ This one is already 2¼ so that's compliant. So you get an idea here, right? So filler material is an option as well as a hardwired gate edge. So in this side-by-side example, you can see the install on the left is likely compliant, but the one on the right is obviously not compliant and needs some filler material. And you see in this example, they screened off properly on the right side, but providing the left gap is within 16 inches, that's considered an entrapment zone, so that should be shielded off as well. So ASTM states that the gate shall not fall over more than 45 degrees from the vertical plane if it becomes detached from the operator. So a typical follower post are used for this, but catch bracket like this one is installed on the gate support. It's a sufficient way to do it. This is a typical follower protection that you'll see out in the field. The standard calls out that the gate cannot move, cannot fall over more than 45 degrees if it becomes detached from the operator. You see this ground track slide gate here, it can't fall over more than a few inches. So these the 4 vertical follower posts to protect anyone standing in the shadow of that gate. That one's well done and in compliance with the standard. So in this swing gate example here, you notice the left gate shows proper compliance with the gap requirement of 16 inches. The configuration on the right leaves a less than 16 inches gap between the gate and the wall, so it requires a photo eye to protect that area. And so if this is out of past 16 inches, you're good. If this gate, when it's in fully open position, is within 16 inches, that's going to require a photo eye. So on a swing gate, you'd have the photo eye normally across the lane, covering your closed direction. Would only need one in the open direction if this entrapment zone exists. It's also required to bring any gap on a slide gate down to 2¼ inches up to 6 feet on the gate panel. So this is an example of a typical picket style gate, but it doesn't matter what type of slide gate it is. There cannot be any gap or any space greater than 2¼ inches up to 6 feet on the gate panel. So when it comes to picket style slide gates, they can be designed like you see in this graphic here. Oftentimes, that's not the case. They're typically going to be 4 inches on center, in which case the option in the field is to use some kind of expanded metal or fabric to bring that gap down to 2¼ inches up to 6 feet. Above 6 feet, 4 inches on center is just fine. And there's no requirement for that gap to be brought down above 6 feet. Also requires that you cover the back frame of the gate. Oftentimes that's missed. People are trying to cut costs and reduce weight, as you see in this example. The old standard used to be up to 4 feet on the gate panel. It is now up to 6 feet. And again, you want to make sure you're covering the back frame. The entire gate panel must be covered and brought down to 2¼ inches up to 6 feet. This also includes the fence line that the gate is moving along. So this fence line would also need to be brought down to 2¼ inches for the full length of travel of the gate. So this particular installation's got a number of issues with it. You can see there's obviously gaps that are wider than 2¼ inches. So there should be some kind of material on that gate up to 6 feet, bringing the gap down to 2¼ and also the access control is likely a little close, and you do not have any warning signs on either the public or secure side of this gate. So in this example, you can see the gate's properly screened, but there's 2 obvious safety standard violations. They screened the pickets to prevent reach through, but they didn't add filler material to reduce the gap on the follower posts on the gate. And also the card reader is installed within 6 feet of the gate, which is a UL violation as well. So yeah, before we go on, just some definitions here. You guys might be already familiar with these, but there's really 2 types of slide gates we're working with. One is cantilever, the other one is ground track or V track. The picture here is what we'll call a type 1 cantilever, typically characterized by 4 wheels, 2 at the top, 2 on the bottom, and it's carrying the weight of that gate as it hovers over the lane. That's a cantilever type 1. Type 2 cantilever would be how it's actually hanging off of a C channel at the top and still hovering across the lane, but it's going to have sealed wheels inside a C channel and hanging across the lane. When it comes to V-tracks, we call this a V-track or a ground track gate, rolling gate, some people also call it. This is another type you'll see out there. We recommend using cantilever gates because they do hover across the lane. Grade issues are not so much of a deal. With ground track, you do have a track that's actually set into concrete. You can see essentially it's an upside down angle iron that's set into concrete with a V-shaped wheel riding on top of it. So you've got issues with trucks riding over that, and over time it comes up, debris catching the wheel, those kinds of things. So there are some maintenance issues with ground track gates, whereas cantilever is typically a better way to go. So you don't want a gate that you specified installed like this. So anytime the gate is disconnected from the operator, it could be a dangerous, hazardous situation where that gate could be a runaway gate down a parking lot, hit a car or somebody. And so ASTM requires that the gate panel cannot move under its own gravity if detached from the gate operator. So there's not a lot of great solutions to this. Obviously, regrading the facility to make sure it's level is one option. So open wheels are pinch points for fingers. All weight bearing wheels on cantilever and V-track gates must be covered per ASTM. Anything above 8 feet is free and clear, no issue. Anything below 8 feet must be covered to protect from pinch points. So ASTM requires that all weight-bearing rollers installed less than 8 feet from grade must be covered. The guide rollers here in this example are not weight-bearing, so they really don't fall under the standard, but it's really a good idea to cover these regardless. And it also is a requirement for your V-track wheels as well. All right, so we come to protrusions. So protrusions, of course, are a puncture hazard when the gate hits a person in either direction of travel. So what's not okay? Gate hardware such as chain adjustment bolts that extend past ½ inch. Bottom pickets, which extend more than ½ inch below the bottom of the gate. Top pickets, which are not in line with the plane of the gate and below 7 feet. And receiver guides in line with the plane of the gate must measure less than 9 inches cross section. And any non-blunt object attached to the leading or trailing edge of the gate protruding more than ½ inch. So the things that are okay are top pickets, provided they are in the vertical plane of the gate. They can, if you notice some of those like Ameristar style gates where the pickets will curve over at the top. That must be 7 feet before it does that. Bottom pickets, which do not protrude past ½ inch from the gate frame, are allowed, and safety devices such as gate edges, of course, are okay. So this is a common installation error when installing chain-driven operators. The bracket should be located on the inside of the post, and the bolt should not extend more than ½ inch past the post. Also, the vertical post shouldn't extend below the horizontal rail more than ½ inch at the bottom here. So that should be cut off and that should be cut back. This bracket should actually be brought back into here, really. And then when it comes to barbed wire, the gate must be a minimum of 6 feet tall for barbed wire and a minimum of 8 feet tall for razor wire. So barbed wire, you can see the one on the left meets the requirement. And the razor wire one on the right is likely less than 8 feet. So that's definitely a violation for razor wire. And ASTM requires the gate be designed with some form of positive stop to prevent the gate from over travel if it becomes detached from the operator. So positive stops must be installed in both directions of travel. So you need something like this. And oftentimes there's a positive stop up here as well. Here's a positive stop for a V-track style gate. The rail is embedded in a roadway surface, and when the gate wheel comes into contact with the upright weldment there, it stops the gate from further travel. So if the design installation is conforming with UL 325 and ASTM F2200, you'll have a successful installation that's going to look much like this. So this is actually a document I can get to you upon request. This is a great cheat sheet. There's more to this document that calls out all the particular items related to these standards. But this particular graphic covers everything in the presentation. So you've got your pedestrian access, you've got your 6 feet minimum for your access control, your photo eyes for both open and closed direction, your gate edges for both open and closed direction. You've got your warning signs on both sides of the gate, your guideposts for fallover protection, and your positive stop. And I missed anything, but that should be it. So that's a pretty good cheat sheet to use to kind of just look and see what's really required for a compliant installation. And we also have a similar thing for the swing gate. So that concludes the AIA portion. I'll take the next 10 minutes or so to just cover a real high level our products. So high security, we cover 4 distinct markets: residential, commercial, industrial, and hostile vehicle mitigation, otherwise known as crash or anti-ram market. On the residential side, we have a couple operators here, a couple of linear actuators for swing gates and one slide gate that's available out there. We call these farm and ranch market, really. Probably something you guys would not likely run into. But the commercial line probably is. Our commercial operators are 24-volt DC electromechanical. They come standard with UPS battery backup capabilities and have solar options. So our newest addition, the Slide Smart Connects and Swing Smart Connects. These guys offer an installer smartphone app for full control from your smartphone for installation and programming. They're also direct drive, so no belts, change or pulleys deal with, toolless wired terminals, and built-in real-time security alerts with what we call our HiNet gateway, which allows internet access to the operator. So you can pull event logs, diagnostics, program the operator remotely, etc. And then when we come to our industrial operators, this is kind of the cash cow for high security. This is where we really got our name, is in the industrial market. Our industrial operators, they're continuous duty, they're hydraulically driven, they contain fewer moving parts, so better reliability. We like to measure their lifespan in decades, typically not years. So we've got many of these that have been out there in play for more than 20 years with very little maintenance. You'll find these specified, of course, in industrial environments, typically class 3, class 4. So typically critical infrastructure environments such as DoD, petrochemicals, substations, data centers, airports, you name it. Slide driver is an operator that will take up to a 20,000-pound gate panel, depending on the model. We have operators that will go up to 3 feet per second. And again, these are all hydraulically driven, and they have UPS battery backup as an option. Hydra Swing, that's basically a linear actuator on steroids. It'll take up to a 40-foot gate panel weighing 15,000 pounds and can withstand heavy wind loads. And then the swing riser there, it's kind of a unique animal. It'll raise the gate panel straight up 4 inches, straight up, pulling the locking pins out of the ground. And then we'll continue to raise the gate for another 8 inches for a full 1-foot rise as it opens up. This operator can take up to a 3,000-pound gate panel. And then our strong arm will span up to 36 feet, covering multiple lanes at once, and offers a unique breakaway feature. And then the Hydra Lift, if you can't swing or slide, we can go straight up. So this guy will take up to an 80-foot wide gate panel weighing 2,000 pounds and raise it 16 feet in the air in about 8 seconds. And then we offer a complete line of hostile vehicle mitigation barriers, which are typically specified in critical infrastructure sites, of course. DoD, petrochem, state, federal, local government, etc., data centers. So they're engineered and field crash tested to ASTM, IWA, and PASS standards, so we can go international with these. And it's common to see these installed with something like our slide driver for a security gate, so sequenced with a crash barrier as well. Strong-Arm M50 and M30, those are field crash tested. They come in 12 to 24-foot arm lengths and will stop at 15,000-pound vehicle, doing 30 or 50 miles an hour. I got a video of that crash test coming up here. And then the Wedge Smart, that's basically our strong arm park integrated with a crash wedge, rated to FS30, which means it'll stop a full-size sedan traveling at 30 miles an hour. These are going to be typically seen in rental car facilities, that kind of thing. You probably have driven through something like that when you rented a car. Hydra Wedge, SM50, it's available in widths between 6.5 to 13 feet in blocking distance. It's field crash tested to ASTM M50, IWA, and PASS, international standards, with 0 penetration. It offers high cycle throughput, open close speeds up to 3 seconds, and we have an EFO, emergency fast operate, of 1 second. And of course, these all have UPS battery backup as options. And then our M30, M50 field crash tested bollards. We have both fixed, removable, and active bollards available to you. And we now also have M30 field crash tested slide gate system. That comes complete as a complete system with a slide driver 50 VF operator. Includes the gate, anchor cages, the crash beam, et cetera. And the infill can be whatever you choose. So that's open. Infill is an optional item. But this is a full system that is M30, and we also will have an M50 rated crash slide gate available, I think, by the end of Q2. Let me show you how these are tested in the field. Here it is. So this is our M30 crash test you just saw there. So what they're doing, the stick right here is measuring the penetration. So that's P1, there's P2, P3. P1 is 1 meter. So they're measuring the back of the cab. How far into the secure zone did the back of the cab go? In case of the M30, it got a P1 very, very easily. All right, so connect with us on all the social medias out there. If you go to our website, the support center is going to be your best friend. That's going to be where the meat and potatoes of all of our operator information is going to be up there, including installation guides, cut sheets, you name it, will be available on the support center. And we have a specification sales team that covers the country. I handle the Western region. Nikki Deno handles Central, and David Wharton handles the Eastern region. And again, we can help you with design, operator recommendation. We just do consultation on these safety standards, just the entire A to Z. We'll stay with you in the project all the way through to the end, to where we recommend contractors to do the installation. As a manufacturer, we do not sell direct or install. We have contractors that are trained and authorized to sell and install our equipment. All right, folks, that is it for me.
Thank you, Brad. We do have a few questions and we've got about 3 minutes left. So hopefully we can get to a few of them before we answer the rest offline. I think the biggest question, the one that's been asked the most times, is how does this relate to tilt-up gates and or roll-up gates?
So I believe there is a UL 325 section for roll-up gates. We don't manufacture roll-up gates. But there is a particular section that has specifics to that, and I'd have to look it up and get back to you on that. Tilt-up gates, yes, those are part of the EL 325 standard and would be, I believe, very similar to like a barrier arm, but I would have to look into that for you as well. It's a good question.
Okay, we can answer that one offline. The other ones that we have, one person asked what the pros and cons of a cantilever slider gate versus a V-groove slider gate is.
Yeah, good question. So cantilever gate is preferred if you can. It hovers over the ground, right? So it's not susceptible to issues with grade. If you have grade variation, the V-track or rolling gate can be kind of problematic. So that's really the main differences. The V-track, it can tend to be more problematic in terms of maintenance, that kind of thing. The V-track comes out of the ground, as trucks roll over it. You've got issues with debris and that kind of thing, causing havoc with wheels. So cantilever is a better way to go, I think.
Awesome, thank you. Looks like we have time for about one more. One person asked horizontal distance required on barrier arm, the distance between the access control device to barrier arm?
Yeah, that would still be 6 feet.
All righty.